Okay, so review, test tomorrow, and I'm going to do all my work on a piece of scratch paper so I can write nice and big so everybody can see it. All right, now if I get going too quickly, let me know. Say it nicely though if I get going too fast. So number one, I'm going to do the square root of 50 m to the 5th. Okay, so I got to break it down. Square root of 50 is an ugly decimal, but if I break it down and reduce it, I can get some good numbers. How about 25 and 2? Because that makes 50, and the square root of 25 is 5. Girls, I know you're paying attention back there. And I want to take half of my exponent, so I'm going to break that down into the square root of m to the 4th square root of m. Okay? Now, I have it broken down so that I can take some square roots. The square root of 25 is 5. I'm going to take half my exponent and make it m to the 2nd. Square root of 2 is not a perfect square, nor is m, so I leave those two as a square root of 2m. That is all.
Wow, that's easy peasy.
Good. I like to hear that. Okay. Okay, number 2. I'm first going to rewrite it as two separate fractions. Square root of 20 y to the 5th over the square root of 9x to the 6th. Okay? Now, first of all, when I look at this problem, well, not really. What I recognize right off the bat is that the bottom, or the denominator,
It can be reduced.
sure can. It goes straight to 3x to the 3rd, right? It goes straight to 3x to the 3rd. Square root of 9 is 3. I can take half of my exponent. But the numerator needs breaking down. 4 and 5, square root of 4, square root of 5. And I'm going to go the square root of y to the 4th and a square root of y, okay? Almost there. Now I just have to take some square roots. So on the numerator or the top, am I going too fast?
No.
Square root of 4 is 2. Take half of that, y squared, and square root of 5 is not a perfect square root. And the square root of y isn't, so I leave those two as square root of 5y. And in the denominator, I just have a 3x to the 3rd. So I've broken down every single square root that I could find. I've taken everything out, reduced as much as possible. That's my answer. Yes?
What if the denominator can't be like?
We're going to rationalize it. That's coming. We'll rationalize it. Yeah, good question. Okay? We got one of those coming, okay? Number 3. I'm going to go negative 4 square roots of 20 plus 2 square roots of 5. Okay? Now, these two can't be added because they're different. So, what I'm going to do is try and break up 20, and hopefully I'll get a square root of 5, and I should. Negative 4 square root of 20 is square root of 4, square root of 5. 2 square roots of 5. 5 is not a perfect root, so I'm going to leave it the way it is. I know the square root of 4 is 2. Negative 4 times 2 is a negative 8 square roots of 5. Bring down the 2 square roots of 5, and they can be actually subtracted because of the negative, but they're the same. So you can combine them. Negative 8 and 2 makes a negative 6 square roots of 5. That's all I need to do. Not too bad. This is mostly a review of what we did our last quiz. Okay, number 4. I'm going to have a 5 square roots of 5 times a 3 square roots of 5 plus a 3 square roots of 25. Okay, how's that look? Kind of sloppy, but there it is. Okay, now wait a minute. Before I do anything, I see something easy. I do see something easy. Sure, right there. What's the square root of 25?
5.
Let's just change it to a plain old 5, right? So if this changes to a plain old 5, then 3 times 5 is 15. So let's rewrite the problem. 5 square roots of 5 times 3 square roots of 5 plus 15. Okay, let's just do that right off the bat. Because I recognize an easy step. Square root of 5 is 5. Square root of 25 is 5. And now let's
Wait, but
distribute.
isn't the other one 15?
You're ahead of me. Okay, so let's distribute. This times this times this, right?
Wait, but I'm sorry. Okay, actually, never mind.
You okay?
No, I'm not.
Well, ask.
Well, okay, so if there's if there's 3 square roots of 5, and that's also 3 square root of 5, so why can't we just change that to 15?
Okay, really good question. It's not, this just is a plain old 5, not a square root of 5, just plain old 5. Square root of 25 is just 5. Just 5. And 3 times regular number makes a 15. There's no square root anymore.
Oh,
That's
I
gone.
got it.
Okay, now let's multiply. Regular number to regular number, whole number with whole number. I'm going to get a 15 square root with square root, square roots of 25 plus regular number, whole number with whole number, square root of 5, square root of 15 makes a 75. 5 times 15, square roots of 5. Okay, so I multiplied regular number with regular number right there. 75, but then you also have to multiply through the square root of 5.
Wait, but what'd you multiply to get 17?
5 times 15. And then there is one last thing I can do, right? Yeah, the square root of 25 is 5. And we just saw that 15 times 5 is 75. Do not add these. Do not add these. This is 75, and this is 75 square roots of 5. You can't add these because they're different. Okay? All right, graph the quadratic. So I'm going to go ahead and get a piece of graph paper out. Okay. A piece of graph paper out. Okay. And I'm going to do number 5 on a piece of graph paper. Yeah. Huh? If I have some alone or two. Oh, I do have some graph paper. Here, you guys want to share it? Here. Pass it around. Here. Pass it around. I'm just going to start, okay? All right, number 5. Y equals x squared minus 2x minus 24, okay? So let's think about some things that we know. Some easy things we know. Is there anything that we know right at the bat to graph this? Did you say factor? You're right. Let's not do that yet. That's not the easiest, but that is easy. Okay, you guys see something else? You're right. We're going to do that. What?
You can subtract 24.
Oh, we don't want to do that.
Subtract 2x.
Not yet.
Subtract.
So, yes, Isabella. Yes, that's what Annie wants. Okay, I'll give it to you. The Y-intercept. What's the Y-intercept?
I have no idea.
Negative 24.
It is 0, negative 24. You guys agree? Y-intercept? We can graph that. That's a point, correct? Right? And now let's factor. Set it equal to 0. And factor. Okay? And if I factor it, minus 6, positive 4, right? So we'll get x equals 6 and x equals negative 4. Now, those are zeros, which are also x-intercepts, okay? Right? So I have x-intercepts at 6, 0 and at negative 4, 0. Now, the vertex. Beside, shh. The vertex. There's 2 ways to get the vertex. 2 ways. One is negative b over 2a, and that will work. The other is this. The vertex has to lie right in the middle of these 2 points. Does that make sense? The vertex is right smack dab in the middle of these 2 points. So if I do a little mini graph real quick, if I kind of like look at what I have so far, and I did this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I know, because we're smart, I know that there is a line of symmetry right here. I know there's got to be a line of symmetry right there because the line of symmetry goes through the middle of the parabola. If I've got a x-intercept of -4, x-intercept of 6, then my vertex is somewhere on x equals 1, isn't it? You could have also done the negative b over 2a. That'll work, sure. But x equals 1. Now, 1 what? Isn't the y value way down here somewhere?
Plug it in.
Plug it in. So if I plug in my 1, plug it in, I'm going to go to y equals 1 squared minus 2 times 1 minus 24, which should give me a negative 25. Let you catch up. So that is going to be my vertex. My vertex is at 0, negative 25. Now I'm not going to get all the way down to 25 unless I go by 2's, right?
Why 0?
Oh, I'm wrong, Landon. You're right. How about negative 25? Thank
Yeah,
you.
you're wrong.
I was wrong, Landon. So I'm going to go by 2's, negative 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, negative 20. So negative 24 is here. So hopefully I'm not going too fast. Yeah, I'm going to need 25. You're totally right. Yeah, yep, because I had to go by 2's, but negative 25 is right there. So I'm going to put a point right there, Zana. You're awesome. Yep. Okay, how am I doing? Okay. Zana's like, no, Mr. Davies, negative 25. Yep. Y-intercept of negative 24, right? I have an invisible point right here. Look at my pen. I've got another point right here, right? I do have another point right there. And I'm just going to sketch it in. Now, Quinn's going to appreciate this.
Yeah.
Because let's say I'm clueless, but I have a calculator, right, Quinn? That will also work, but you got to be careful on your window, right? Okay. How am I doing? Not too fast? All right.
Oh, yeah.
Slip this away, and let's do number 6, okay? Number 6 is solve by square roots, okay? 6, I'm going to have 2x squared minus 1 or minus 7 equals 1. Okay, what does it mean by square roots, huh? It won't factor. So what do I mean by square roots? Well, we're going to have to take a square root, right? But let's simplify it first. Plus 7 plus 7. You okay with that? Plus 7 plus 7. 2x squared equals 8. Divide by 2. Divide by 2. X squared equals 4. How many answers?
2.
How many answers?
2.
So square root, what's the square root of 4?
2.
And negative 2 plus or minus 2. Nice job. That was pretty easy, wasn't it? You guys agree?
Yes.
Yeah. And 2 answers. What do you know? Are you ready for number 7, or am I going too fast? Okay. I'll wait for you, Jay. Okay, 7. Slide this up. Parentheses, x minus 4 squared minus 1 equals 8. Okay, so we're going to take a square root, but first, let's simplify as much as we can. How about plus 1 plus 1? You okay with that?
Yes.
Parentheses, x minus 4 squared equals 9. Right? Square root. How many answers? Yep, I'll slow down. Square root. How many answers?
2.
Right? So what's the square root of 9? And negative 3. So we're going to say, and I'll let you catch up. Yeah, x minus 4 equals plus or minus 3. Now if I need 2 answers from this, I need 2 equations. If I need 2 answers, I need 2 equations.
Pass the board.
So I'm going to go an x minus 4 equals 3, and we'll do an x minus 4 equals a negative 3. How am I doing? So I'm going to get 2 answers, aren't I? Got 2 equations. I'm going to get 2 answers. Plus 4, 1 answer is 7. Plus 4, the other answer is 1. 2 answers. There you go. right, whip this away when you're ready. Okay, number 8. Going. All right, number 8. We have completing the square. Okay, number 8. Mr. Massey says, if you are going to go to pre-calculus, he says you better know how to complete the square.
Molly said they don't do that.
Well, Mr. Massey says so because maybe they just haven't done it yet.
Molly, alright, take it pre-calc.
I don't know. Okay, so remember complete the square. Let's write this down. Half of 16. What's half of 16?
4.
Half.
8.
8. And then we're going to square that. So if you square 8, what do you get? 64. Now, it's got an equal sign. It's equal. It's balanced. So if I go plus 64 here, to keep it balanced, I better add 64 here. Got to keep it balanced, right? So it's equal. So if I add 64, I better add 64 here to keep it equal and balanced, right? Okay, now why did I complete the square? Because I can factor. I should be able to factor this. Okay? All right, how does this factor? What times what makes 64 that would add up to 16? Yeah, 8, right? So it would be an x plus 8. X plus 8 equals, let's see, is 81? Is that an 81?
Yeah.
Yeah. Okay, this can be rewritten because there's 2 of them. X plus 8 quantity squared equals 81. Okay, we've completed the square. Looks pretty slick, doesn't it? And now,
3 square root.
and how many answers?
2.
2 answers, square root, right? So I'm going to have a x.
Plus 8 equals plus or minus 1.
Yeah, nice job, Landon. Okay, if we're going to have 2 answers, let's have 2 equations. If we're going to have 2 answers, let's have 2 equations. Let's have an x plus 8 equals 9, and an x plus 8 equals negative 9, right? And let's solve. Minus 8, one answer is 1. Minus 8, the other answer is negative 17. And I skipped a little step, but we're in geometry. We know how to do that. How am I doing?
Wait, negative 17?
Yeah, negative 7.
Yeah.
No.
Yeah, because you plug
Minus 8.
Oh, yeah.
Sometimes. I'm wrong quite
Wait,
often.
were you in the same boat as me?
Yeah.
Okay, good.
All right, number 9. Number 9 should be easy. At least I'm hoping, right?
You are?
X squared minus 36 equals 0. It says by factoring, right? By factoring. Roy, what's that going to factor into? Yep. X plus 6 and x minus 6. Okay. I'm going to get 2 answers. I've got my mini equations. I don't need to do that, do I? Go straight to x equals negative 6 and x equals positive 6. You okay with that? Yeah. That's it. Done. That should be one of the easiest questions on the test, right? All right. We'll wait for you, Landon. I'll write down 10 and I'll wait for you, okay? I know, it's all right there. I know. Yep, it is. That's the sad part. It really is there. Okay, you ready? Slide it up. So if we're going to go by factoring and we want to get the zeros, I'll say it again. If we want to factor, we want the zeros, we have to let it equal 0, correct? So let's bring over the 48. How do I bring 48 over? Well, subtract it. Zoe's right. Subtract it. X squared minus 2x minus 48 equals 0, right? Okay, then what?
Factor.
Factor, sure. What times what?
X.
Yep.
24?
Nope.
No.
8 and 6.
8 and 6.
How about a negative 8?
And 8.
Positive 6. There we go. If we solve our mini equations, I'm going to skip the step because you guys know we're going to get x equals a positive 8 and x equal to negative 6 with my mini equations, right? But I'm skipping that because we're not in algebra anymore. We know how to do that, right? Yeah. Okay. Turn the page.
Yeah.
All right, number 11. Oh, we got lots of time,
I
Landon.
don't think we've ever worked with
11. No, we're going to start that after this chapter, actually. 3x squared plus 4x plus 1 equals 0. Okay, now, when I factor with a leading coefficient, I'm going to have to check my middle term with a double smiley, right? So what times what makes 3x squared? 3x and x, right? What times what makes 1? 1 and 1. Where's my 4? Well, if we check with our double smiley, we should get a 1x and a 3x, which do make the positive 4x if it's plus plus. Now, we're not done because we're solving, right? So we get our mini equations. 3x plus 1 equals 0, x plus 1 equals 0, because if either one of these are 0, the whole thing's 0.
Wait, 4 or 5. So it's just 0?
So one answer is negative 1/3. I bet I went too fast on that one.
Why?
Zoe?
I'm really confused. How is it 3 and 1 equals 4?
Yes.
And 1 equals 5. 3 and 1 equals 4. Plus 1 is 5. 3 times 1 is 3.
Thank you. Got it. And x equals negative 1. Zoe, you good?
Yeah.
It's all right. It's kind of a Monday, isn't it?
Uh-huh.
Yeah. Yeah, it's even a worse Monday because we had 3 days for our brain to go to sleep, right? Yeah. Okay, you ready for number 12? Slide it up. Getting there. 20x squared minus x equals 12. Okay, so if we're going to find the zeros, let's make it equal 0. If we're going to find the zeros, let's make it equal 0. Let's bring over the 12 and put the 12 comes over here. Becomes a negative 12, right, because I have to subtract it. 20x squared minus, I'm going to put a 1x minus 12 equals 0. Now this one's a little bit harder. So I'm going to make sure I use my pencil so I can erase in case the combinations don't work. But I'm going to guess 5x and 4x, right? I'm going to guess that. I'm probably going to try 3 and 4. 3 and 4, right? All right, double smiley. That's a 20 and that's a 12. That's not going to make a 1, is it?
Wow.
No.
We can't factor.
Well,
What?
how about a 2 and a, how about a 4 and a 3 like this?
You're supposed to know that.
Oh, switch around my work. Check it out. So here's a 15 and a 16. If this was a negative 16, a positive 15, I think it's going to work, right? But we're not done. We have our mini equations. We're going to have a 5x minus 4 equals 0 and a 4x plus 3 equals 0, right? And I need to solve. I can solve in my head because we're pretty quick and we're pretty smart. If I add 4, then divide by 5, I'll have 4/5. If I subtract 3 and divide by 4, I'll have a negative 3/4. Okay? Thumbs up? Thanks, Julia. 13 and 14 are easy except for a couple of little things. But I'm going to make sure that we do it. Okay, so let me know when you're ready. Everybody done with 12? Okay. All right, let's do number 13. We have a 7 minus a 5i minus a negative 5 plus a 2i. Okay, now, all you have to do is to be careful is the double negative, okay? You got to be careful of double negative because a minus 5. In fact, what I'm going to do to make this really easy for myself is I'm just not going to make a dumb mistake. I'm going to bring the negative through first. Bring the negative through first. So this is going to become a positive 5 and a negative 2i. You okay with that? before I do anything. I don't like to make dumb mistakes. So I'm going to bring the negative through. Positive 5 and a negative 2i, okay? Now let's combine like terms. 12, 7 plus 5. These are real numbers. Add the reals. 12. Negative 5i minus 2i makes a negative 7i.
That's it.
You just have to be careful of the double negatives, okay? Same thing tomorrow. Be careful of your subtracted negative. Make sure you subtract the 2i, okay? Okay, 14. I'm getting there, aren't I? I have a 1 minus a 3i times a 4 plus a 3i. So before I even start, I'm going to do myself a little box over here to remember. Big important thing. Remember, before I do this problem, that I squared, I got to remember this, that I squared is equal to negative 1. Okay, I'm going to put that there. I need to remember that I squared is equal to negative 1. Okay? We've talked about this before. So I'm just going to FOIL. Okay, I'm just going to FOIL. 1 times 4 is 4. 1 times a 3i is a positive 3i. Negative 3i times 4 is a negative 12i. And negative 3i times 3i is a negative 9i squared. Okay, now I have to remember that I squared is equal to a negative 1, right? So I'm going to rewrite that as a negative 1. So I'm going to have a 4 plus a 3i minus a 12i minus 9 times negative 1. Okay, I got to remember to change that I squared into a negative 1. Now, let's simplify. These two are the same. They can be combined. I have a 4 minus a 9i, because 3 minus 12, and then I'll have a positive 9. Negative 9 times negative 1. Negative 9 times negative 1. Okay, these are real numbers. I can put my real numbers together. 4 plus 9 is 13 minus 9i.
That's it.
That's it. Oh, that was so well said. Thank you.
There's a backside.
Nice. Thanks, Hannah. Okay, now I don't have to do the back, but you probably want me to, right? Okay. All right, I could probably do 15 here. Okay, 15, I have, we can do this. This is what we just talked about. X squared minus x is greater than 30, okay? So, first, let's find its zeros. Let's find its border points. So let's bring the 30 over. Okay, how do I bring the 30 over?
Minus it.
Yep. Bring it over, subtract it. So I'll have a x squared minus a 1x minus a 30 is greater than 0, okay? Look for zeros, so let's set it equal to 0 and factor. X squared minus a 1x minus 30 equals 0. So let's set it equal to 0 and find its border points, or where it's equal to 0, okay? Factor, okay, xx, what numbers am I going to use? Multiples of 30 that make a negative 1. Thanks, Rory. Negative 6, positive 5. Or our zeros are just going to be the opposite. Our mini equations, right? X is equal to positive 6 and x is equal to negative 5, okay? So I'm going to have a number line. I'll have negative 5 and 6. Okay, now I need to shade, so I've got to get out my pencil to shade. And real quick, am I going to go a solid dot at negative 5 or an open dot? Open, because it doesn't equal these values. So open dot. Isai,
Yeah?
what did you tell me earlier? It's greater than. Which way do I shade?
You put me on the
Does
spot.
anybody remember? Outside. Thank you, Hannah. Now you can test a point. You can test 0. Well, you were the one who said it. You were the one
We have
who.
to test it if we know which way already.
You don't have to test it.
Then let's not test it.
Okay. If you're unsure, you can test it. How's that, Landon? If you doubt it, test it.
Wait, but
Wait,
if it's
why
always that way, then why do we doubt it?
It's always that way, and we'll change it up when you go to Algebra 2, okay?
Wait, it's always on the outside?
If it's greater than.
Oh.
If it's greater than, so if it's greater than or greater than or equal to, it's outside. If it's less than or less than or equal to, it's inside. Now, you have this, don't you? You have this.
Wait, if x
You ha-
is greater than or if
If the sign is greater than,
I don't know what.
that's greater than. Here, do you have this? Here, now you do.
No,
Okay, turn the page. Or if you're in doubt, test a point, Landon.
Wait, so we
now
have shade
drop out.
the other side?
Actually, can
Huh?
That was so good.
I made it
When in doubt, chalk out.
drop out.
Oh, drop out.
What's shocked?
Okay, now. Shh. I'm getting there. I know we've got a lot to do. It's a long worksheet, but you probably want me to do the end, don't you? Okay, so let's take a look at it. So 16, there's two ways to do it. You could graph it on a calculator. There you go. So there's two ways. Quinn, I know you're listening. Two ways. You can graph it, and you can get the answer by using your intersection pointer calculator, okay? Or I'm going to do it the way Zoe said it. I'm going to set them equal, and I'm going to factor. So I'm going to go x squared minus 4 equals negative x minus 2. Okay, I'm going to do it by factoring. So if I were to solve, I'm going to bring over my negative x. I'm going to bring over my negative 2. So I'll have an x squared plus an x. And I'll go add my 2, negative 4 plus 2 equals 0. Okay? These two make a negative 2. Okay? How am I doing? So, in this case, I can factor, can't I? And if I factor, I want to have x plus 2x minus 1 because they will combine to make the middle term of 1. I'll slow down. So what I did is I set them equal because I think for me it's easier just to do it algebraically. Okay. So if I set them equal, brought over the x, brought over the negative 2, and it factored. So one answer is x equals negative 2. The other answer is x equals 1. Now, these are points because really the graph is a parabola and a line. Okay, so I have a negative 2 something and a 1 something. To get its corresponding y value, I can plug it into either equation. Doesn't matter. This one looks like the easier equation to plug it into. You agree? Probably that one. Look, that looks easier to work with. So if I take my negative 2 and plug it in there, I'd have a negative 2 minus 2, which is like really 2 minus 2, which is 0. And if I plugged in my 1, I'd have a negative 3 is right. Because the graph looks something like this. We don't have to be perfect on it, but it really does look something like this. And that's where they would intersect. It does look something like that. Maybe. Okay. 17, 18. You can do it on your calculator. Want me to show that real quickly? How to do it on the calculator again?
Was it just like homework?
Yeah. No. Save that one. That's like homework on Friday.
Yeah.
All right.
Wait, we did it. It was like the homework we did Friday.
Wait, 17?
Yeah.
Do it?
Yeah, can you show me that?
Because I didn't do it.
All right. Borrow your calculator, okay?
Do we have to on the calculator?
It's just easier.
19 and 20.
Okay, 17. Real quick, if I were to do it on the calculator, y equals, and I'm going to do my 6 minus x squared, right? And guys, shh, shh, shh. I'm getting there. I know. I can stop now. Move it over. Greater than. Shade.
Oh, wait. So we have to be able to do that?
Yeah, I can show you later.
It's really easy.
Okay. Clear. 18, 9, subtract x, squared, make it less than, right? And then do the x squared plus 5x minus 6 and make it greater than, right? Got it?
Wait, do we have to find where's the...
No, just give me a close sketch of it.
Okay.
Yeah. There's the first one. There's the second one. I might want to make my window a little bit bigger. Okay. There we go. And where they overlap is where you want to shade darker, right? Okay, I've only got 6 minutes, don't I?
Yes.
Okay, so
19 and 20.
19 is not too bad. Polynomial, so for the area, it's just going to be length times width, right? So for the frame only, the length is a 3x plus 1. Do you see that? 3x plus 1. The width is going to be a 2x plus 8. Okay. See a 3x plus 1 and a 2x plus 8?
Where do you want it?
8's right there.
Oh, never mind.
Oh, hold on. Plus 6. I almost made a mistake.
What happened? Why is there a 3? Oh.
X and 2x.
So wait, instead of the 1, it's a 6?
Well, 1 plus the 6.
Oh. And then you multiply those by...
Yeah, because it's area, so we multiply, right?
Why am I getting cold?
Okay, I'll walk you through it. Watch.